Okay, guys, so we've got the same situation that we usually do. This is phase 6. The practice for this is on delta math. So we've got a particle moving along the x-axis. Time is always greater than 0. Here's its position. Determine all intervals where the speed of the particle is increasing. So speed increasing means speeding up. Okay, so speed increasing means speeding up. So speeding up, a particle is going to be speeding up when, if you look at this thing, you will see at the bottom when either velocity and acceleration are both positive or velocity and acceleration are both negative. So I got to find, this is the position function, so I need velocity, which is the first derivative, and acceleration, which is the second derivative. Now for number 3, guys, I'm going to show you another way of doing this, like just in your calculator, which is kind of nice. All right, so velocity is the first derivative, negative 20t to the third t. All right, now to figure out where velocity is positive or negative, I need to use a sign test. And when you need to use a sign test, like a number line, and you do the signs, that's where you do the critical numbers and then separate the number line with those. So, just a minute. Okay. Yeah, so the first thing you do is you want to set this equal to 0, so I'm going to factor. I'm going to take out, I see that I can take out a negative 20t right away, so I'm just going to do that. T squared minus 3 equals 0. Okay. So, yeah, and then you don't have to do this, guys. Like, you could just set this equal to 0 on its own, and you're going to end up getting t equals plus or minus radical 3. And then when you do that, you throw out the minus because time can't be negative. But I'm going to do a difference of 2 squares on this. T plus radical 3, t minus radical 3 equals 0. So that's how you do a difference of 2 squares on something if the second term is not a perfect square. You just take the square root of it like that. It's kind of nice. Okay, now, so I'm not doing a whole big number line because time is greater than or equal to 0. So the critical numbers here are 0, but that's like an endpoint also. And then this factor would give us negative radical 3, which we're not even considering. And then this would give us positive radical 3, so right there. Yeah, so I just got to do a sign test like here. So what could I plug in here? Like 1 is less than radical 3. So like if I could plug in 1, I would get a negative, positive, and a negative. So that'd be positive. And then beyond radical 3, like 5 or 20 or 100 or something, you would get negative, positive, positive. So that'd be a negative. Okay, so there's the signs for that, for velocity. Now acceleration. It's the second derivative, so this is negative 60t squared plus 60. All right, and then I could factor out negative 60 t squared minus 1, my bad. Negative 60. All right, so here's going to be the acceleration graph. The critical numbers for here would be negative 1 and 1, but we got to start at 0, so it's just going to be 1. Okay, you plug something in here. Oh, no, it wouldn't be 0. 0 wouldn't be a thing. Yeah, duh. This is not, 0 is not one of them. 0 is not a critical number. Okay, so, yeah, you know what, guys? Since 0 is not a critical number, okay, so if this were not a velocity, if this were not like a situation where t is greater than or equal to 0, then we would have these critical numbers instead. So 0 would be a testing point. So I can plug here, 0 cannot be a testing point because it actually is one of the critical numbers. Like for this situation, if it were not, You know, if we didn't have the same context, our number line would look like this, and 0 would be a critical number. But for this situation, 0 is not a critical number. So even though I have it on my graph because it's an endpoint, here it is a critical number, here it's not. So here I could not use 0 as a testing point, but here I actually can. And I just say that, guys, because like otherwise you'd have to plug in a fraction. So maybe it would be easier for you to just plug 0 in, and then you get negative, negative, positive, negative, right? Negative, positive, negative, which is positive. But you could also like plug in a half. You know, you'd still get negative, positive, negative. That's probably just as easy for you guys. And then I plug in something over here, and I get negative, positive, positive. Okay, so basically, guys, we're looking for where velocity and acceleration are both greater than 0, or velocity and acceleration are both less than 0. And here I'm going to put these together, these two things together. So if they're both positive, so velocity is positive here, okay, and acceleration is positive there, okay. So here is where, you know, we've got that overlap. So here's where velocity and acceleration are both positive. Now where are they both negative? Velocity is negative there. Oh, and acceleration is negative there. So we're looking for overlap, so it'd be like beyond that. So the answer is speeding up. Speeding up is the same as the speed is increasing. From 0 to 1, union, radical 3, infinity. And guys, if you don't need the number lines like together the way that I do, then good for you. Okay, so a particle moves along the x-axis. So at this, yeah, same introduction all the time. But this time we've got the velocity function. Determine all intervals when the particle is moving to the right. Guys, the particle is moving to the right if the velocity is positive. So then, you know that fact, but you ask yourself, do I take the derivative of this or not? Because you know velocity is the first derivative. No, we don't take the derivative because this is already velocity. Guys, they've given it to us already. Okay, so I want to know where velocity is positive because I'm looking for the intervals where the particle is moving to the right. So I just take this velocity, I set it equal to 0. I could take out a negative 4t squared. And then we got t minus 12. All right, so, all right, now 0, it is a critical number here because it'd be a critical number there. And then 12. The reason I say that is because like you couldn't plug 0 in as a testing point because it is a critical number. All right, now I'm doing a sign test. This is velocity. So something between here and you'd get negative, you get negative, positive. You get negative, positive, negative. So positive. And then something over here, you'd get negative, positive, positive. So that'd be negative. Okay, so it's moving to the right on this interval here. So the answer is from 0 to 12, right? Because velocity is positive. So a particle moves along the x-axis, so at this time its velocity is given by this. Determine all intervals where the speed of the particle is decreasing. Guys, this is very similar to this first problem, except instead of having to take the first derivative, we've got the first derivative. So you could just go directly to finding the zeros of this in a number line, and then you take the second derivative, which is acceleration, and then do the same thing. And then the speed of the particle is decreasing. So slowing down is what that means. So you'd be looking for opposite signs. But I want to show you something. I want to show you a calculator way if you want. All right, here's a calculator way. Okay, but then I'll say don't practice with this all the time. All right, I'm going to show you a calculator way, but don't practice with this all the time because they're not going to release like the format of your AP test, which is only going to be 45 minutes. They're not going to release the format of it until April 1st. So I don't know what's going to be calculator, what's going to be non-calculator. I don't know. So you want to be able to do a problem like this without the calculator. But I just want to show you this in case, you know, you could use it. So the speed is decreasing. All right, so guys, speed at any time t is equal to the absolute value of velocity. And you could go to your calculator. If you want to graph the speed function, you just graph the absolute value of this velocity function. So you could go math. Do you see that? That's adorable. Enough, Walter. Enough of being adorable. So this is 15 minus 30. Yeah, so this, I'm doing absolute values around the velocity function, so that's going to be the speed function. Oh. Okay. I want to know what the velocity one looks like. 15x squared minus 30x. Right, so the red one will be, okay, so the red one is velocity and the blue one is speed. And so, what am I doing? I don't want that anymore. Alrighty. So, window, maybe let me go from x min, x max. So y min -1, y max, I'll do like 30. Just so I can see better. Okay, yeah. All right, so they want to know when the speed is decreasing, which is the same as slowing down, but it looks like it's decreasing from, oh, time at t is greater than 0. So I'm only considering, so window. Yeah, so that's the speed graph. There it is. Okay, decreasing just from here to here. So that looks like 1. Let me make sure that 1 is a 0 by, it looks like 1 and 2. No, I'm sure that it is. Yeah, I'm sure that is. Okay, so this is like from 1 to 2. Yeah, we're good. I could verify it algebraically. Actually, maybe I should. No, never mind. I'm sorry. Yeah, we're good. Okay, so from 1 to 2. I graphed absolute value of 15t squared minus 30t in calculator and saw something like this. That's 1 and that's 2. So it'd be decreasing here. Okay. Yeah, so there's that, guys. So you could practice on Delta Math.